Alrighty, I just wanted to go over the answers to the homework with you. This is the answer key for the homework for 3.3. So number one is just making sure you know how to differentiate between when you would use the actual theorems and when you would use the converse of the theorems. I know it seems like a tiny difference, but you use it in two completely different ways. If you already know that the lines are parallel, you are going to use the theorems. So if you are looking at a proof and one of the givens says that you have parallel lines, you're almost guaranteed going to be using AIA, AEA, CA, or SSIA theorems. One of those, SSIA, actually is a postulate, but I would never take off if you said theorem. Now, on the other hand, for B, if you are seeing that it says that you are proving that lines are parallel, then you are going to be using the converse of the alternate interior angles, alternate exterior angles, corresponding angles, and SSIA theorems. Just remember that converse isn't necessarily specific to when you're talking about parallel lines. There's any if-then statement, you can write a converse of it. You just flip the hypothesis and conclusion. For example, the Pythagorean theorem is a if-then statement. If you have a right triangle, then a squared plus b squared equals c squared. And you can have the converse. If a squared plus b squared equals c squared, then it is going to be a right triangle. So those if-then statements, you can have a converse of them. On number two, I gave you some information about some angles, and you had to figure out if there was enough information to say the two lines were parallel. What was the difficult part about this is just making sure that you are able to ignore the lines that don't matter. Even before you start a problem, before you look at the diagram, you have to ask yourself what type of angles you're hoping for. So in A, it says 2 and 9 are supplementary. The only type of angles that we care about being supplementary would be SSIAs. So we're hoping that 2 and 9 are going to be SSIAs. When you take a look at 2 and 9, and you look at those intersections, that would be line 1 and line 3 that might be parallel, and line 4 is the transversal. Since angle 2 and angle 9 are going to be SSIAs, that is enough, and that's why I said that the two lines were parallel by the converse of SSIA postulate. Next, it says 23 and 3 are going to be congruent. We're hoping that they are corresponding, alternate interior angles or alternate exterior angles. So when you look at 23 and you look at 23 and 3, 23 and 3 are going to be alternate interior angles, with L4 and L5 being the lines and L1 being the transversal, and you would just ignore everything else. So therefore, there is enough information to say that those two lines are parallel by the converse of AIA. The next one says 8 and 10 are going to be congruent. We're hoping they are alternate interior angles, corresponding angles, or alternate exterior. But when you look at 8 and 10, 8 and 10 are SSIAs. That's going to be line 2, line 3, and line 4 is a transversal. And 8 and 10 are SSIAs, which should be supplementary, but it says congruent. So that's not enough information. The next one says that 11 and 6 are congruent. That's basically what that's saying. So we are hoping that those are one of those special types of angles, alternate interior, alternate exterior, are corresponding. When you look at 11 and 6, 11 and 6 are going to be alternate exterior angles for L2, L3, with L4 as the transversal. I know some people get concerned because they think that 6 is on the interior, and while it is on the interior between L1 and L2, the intersections that we're talking about that have 11 and 6 are going to be, I don't know if you could see my cursor, but they are the intersections of L2, L3, and L4. So you can kind of ignore the rest of it. The next one says 5 is congruent to 8, but when you look at 5 and 8, those are just vertical angles. Vertical angles are always congruent. That does not help us know that things are parallel. The next one says that you have two angles that add to be 180, aka supplementary. So when you look at 23 and 13, 23 and 13 are going to be SSIAs. You're ignoring the intersection that L2 is making. So it's just L1 and L3 that might be parallel, and L5 is the transversal. 23 and 13 are SSIAs. So they are supplementary, which is given, and that would be the two lines are going to be parallel by the converse of SSIA postulate. The last one says 18 and 7 are going to be congruent, so we're hoping for corresponding alternate interior or alternate exterior. And when you look at 18 and you look at 7, 18 and 7 are going to be looking at L4 and L5 with the transversal of L2. And you would be ignoring all of the other stuff with L3 and L1. And when you look at 18 and 7, they are corresponding angles. So you would say they are parallel by the converse of corresponding angles theorem. Next, what we have here is a proof. Remember, when you look at your givens and you look at your prove part, it will give you hints as to what you're going to be doing. So since they tell you in the givens that you have parallel lines, you know you're going to be either using alternate interior, alternate exterior, corresponding, or SSIA theorems. Most likely not SSIA because we care about congruence in this proof and not supplementary. So once you know that L and M are parallel, L and M are going to be linking together 1 and 2 because they are alternate interior angles. So it's going to be AIA theorem. It made sense for the stuff about the parallel to go first because you can't use those theorems until you know things are parallel. After that, you put the other given. By process of elimination, you're only left with the given of 1 is congruent to 3. Now, this is where people get messed up. When you're looking at 2 and 3, if you just look at the diagram, you're going to be tempted to say that's alternate exterior angles theorem. But you can't use that for the answer for 4 because you need to know that the lines are parallel first, and that's what we're proving. So instead of alternate exterior angles theorem, we used substitution or transitive property. And then lastly, now we can say that the lines are parallel by the converse of the alternate exterior angles theorem. On number 4, we are doing a flow proof. So you have two different givens. The first given I said was 1 is congruent to 3. You could have also had, let's see, what could we have had? This arrow, let me go through here. I think I have one arrow that shouldn't be there. This arrow in the middle, between those two middle boxes that are pointing. Let me check. Nope, the arrow should be there. Sorry. So you have 1 is congruent to 3. You also have A is parallel to B. A is parallel to B leads you to know that 1 and 2 are going to be congruent by AEA theorem. And then when you know 1 is to 2 and 1 is to 3, then 2 must be congruent to 3 by sub or trans. And now that you know 2 and 3 are going to be congruent by sub or trans, now you can say that the lines are parallel by the converse of corresponding angles theorem. If you accidentally said that 2 is congruent to 3 by the corresponding angles theorem, that can't be the case because we don't know the lines are parallel yet. So hopefully that all made sense to you. Make sure you know when you use the theorems and when you use the converse. And remember, in the givens and in the prove, it will give you hints as to which tools you are going to be using. Thanks for watching.